Hello everybody, this is the final lesson in the probability unit. This is about probability of independent events. So in the previous lesson we talked about conditional probability. Those events are called dependent because the outcome of the second event depends on the outcome of the first event. But independent events, we don't have that problem. They don't depend on each other. They happen independently. Think, for example, if I flip a coin and I roll a die at the same time. Whatever happens with the coin is not going to affect the outcome of the die and vice versa. So those would be considered independent events. So what we're calculating is we are calculating the probability of A and B is just equal to their individual probabilities. Probability of A times the probability of B. And again, just like we did in the conditional probability, we are going to be making a tree diagram. We're going to multiply the branches of the trees of whatever the outcome is that we are looking for. And if we are calculating multiple probabilities, we're going to add those two numbers together to get the total. So we're just going to take a look at two examples, but these examples kind of follow the format of the previous lesson. So let's just get started. So example 1 says, a box contains 2 red marbles and 3 white marbles. The second box contains 4 red marbles and 4 white marbles. A person is going to select one of the boxes and then pick a marble. So what is the probability that from whatever box they pick, they're going to get a white marble? So again, we talked in the last video about like how do we make our branches. Well, from one box, we're going to get a branch with the red and white marbles. And from the other box, we're going to get a branch of red and white marbles. So my first event that I'm considering is which box am I picking? So we have box number 1 and box number 2. And there's nothing special about either of these boxes. We're just picking one of them at random. So that is a 1 out of 2 chance or a 50% chance or 0.5, however you want to think about it. But the point is it's a 50-50 chance of whichever box I pick. But what is not 50-50 is the amount of white marbles and red marbles within those boxes. So in my first box, I have 2 red and I have 3 white marbles. So my red is going to be 2 out of 5. My white is going to be 3 out of 5. The second box has 4 red and 4 white. So for red, I have a 4 out of 8 chance, and for white, I have 4 out of 8. Again, the 8 comes from the 8 total marbles. The 4s come from the amount of each of those colors within the box. So what is the probability that a person will pick a white marble? Well, again, I like using a highlighter to show this. So if we pick box 1, this is my probability of picking white. And if I pick box 2, this is my probability of picking white. So we're just going to multiply each of those sets of fractions together. We are going to get either a fraction or a decimal answer, and then we're going to add our answers together. So for box 1, it is 1/2 times 3 over 5, which is just 3 out of 10, which if you're good at changing things to decimals, just divide the top by the bottom number, is 0.3. If we do the same thing with the second one, again, I have a 1 out of 2 chance of picking that box, and then a 4 out of 8 chance of picking a white marble from that box. So we have a 4 out of 16 chance of getting a white marble from that one, which is 0.25 as a decimal. So I'm just going to kind of write it off to the side here. The probability of getting a white marble is equal to 0.3 plus 0.25, which is 0.55. And again, if you want to change it to a fraction, if you want to change it to a percentage, you are more than welcome to. But long story short, we have a 55% chance of selecting a white marble. We only have one more example here. Example 2 says, during a flu epidemic, 35% of students have the flu. Of the students that have the flu, 90% have a high temperature, but a high temperature is also possible without the flu. And it says the school nurse estimates that 12% of those that don't have the flu will also have a high temperature. So again, when we go to make our branches, we have two probabilities here that have to do with having a high temperature. So those are going to be my second branches that I make. And my first branch is just going to be how many students have the flu. So when I go to draw a tree diagram, we have flu and we have no flu. So there is a 35% chance of having the flu, which means a 65% chance of not having the flu. And then from there, we can either have a high temperature or we can have, I'm going to call it a low temperature. I don't know what the difference is. I guess not high. But if you have the flu, 90% have a high temperature, which means 10% have a low temperature. And if you don't have the flu, you have a 12% chance of having a high temperature, and you have an 88% chance of having a low temperature. Okay, so this is what our tree diagram is going to look like. Now we're going to draw our branches and see what we're calculating. So we want to calculate the percentage of students that have a high temperature. So we could have flu and high, or we could have no flu and high. So those are my two calculations that I'm going to make. And then we are going to just add those two answers together to get the total. So for the first one, I have 0.35 times 0.90, or 0.9. And for the second one, you have 0.65 times 0.12. Now you might be wondering, well, can't I just do this calculation by reading the percentages that are in the question? And technically the answer is yes, as long as you keep in mind that 65% that don't have the flu. So that's why I recommend drawing a tree diagram. I think it's a good way to visualize what just what it is that you are trying to find. It's a good visual way to see the branches, see the numbers, see the calculations that you have to make. So we got 0.315 for the first one, 0.078 for the second one. So when we add those two together, we get 0.393. But the question is asking for a percentage. So again, just times it by 100, you get 39.3%. Okay, so again, this lesson really continues off of the previous lesson. The only thing that's different is now we are considering events that are independent of each other. But the formula is the same. The way that you answer the questions and approach the questions, those are the same. So yeah, try some of the practice questions and make sure that you ask your teacher if you have any questions.